We are continuing with our C programming lecture series. Last lecture we have discussed about the relational operator working process, followed by operator precedence and associativity with arithmetic operators. I hope you like that part. This lecture I am going to discuss about another set of operator, that is logical operators. This set of operators are normally used, here you can see, to combine or invert a condition. Here normally we can write the condition, with the if statement, for loop, okay, while loop, and also we are also write in the do while loop. Right. So once I finish this logical operators, we are going to see first one is the if statement, that is we call conditional statement. But without this, we can also write the conditional statement by using relational operators that we have discussed in the last lecture. Relational operators, right? Okay. So in the logical operators, there are only three operators are listed. One is logical AND. I hope you're familiar that operator here. We used it with the scanf as an ampersand. Remember, in scanf we have only used it in front of an identifier name to get the address of the memory block. But here we're going to use 2 times without any space, and that one will be considered as logical AND operator. And logical AND operator returns true means 1 if both the condition are true. Okay, if both the condition are true. So here when you say condition, it can be any valid expression containing other operator and operands. Okay, containing other operator and operands. Note down this, operator and operands. So that's why I have mentioned here we can write the condition with the relational operator. Mainly we write the condition with the relational operator along with if else, along with the if statement and other 3 loops, right? And on the other side, logical OR operator returns true if any one condition is true. So there will be 2 conditions. So normally we write in this way: A logical and B. So 2 condition. Okay, clear? We normally also write A logical or B. So there is also 2 condition. So it is stating that here if both of them is true, this particular expression if evaluates to true, and if this particular expression also evaluates to true, then the complete outcome of this expression will also be determined as true. Similarly here, anyone, that's why it is called OR, logical OR, right? In logical OR, if A evaluates to true, then expression outcome will be true. Suppose if A evaluates to false, then second part of the logical OR operator, right hand side, okay, that is the second condition represented by B, need to be evaluated, and if it is evaluates to true, then only it is true. Okay, if both of them evaluates to false, outcome will also be false, right? So what is the difference between these two, logical AND and logical OR? They need both condition need to be true. That means both conditions are considered to evaluate the expression, and here any one. And at last we have logical NOT operator that we have already seen with relational operator, not equal to. We have written like this in relational operator without any space. Now here only explanatory symbol we are going to consider, and inverts the logical value of a condition, means it used to revert the decision. True will become false and false will become true. Out of these three, first two is the binary set of operators, means they need two operands. Here operands will be in the form of condition, and the last one can work with only one operand, that is only the one condition. Okay, so let us just move to the online GDB compiler and see the demonstration, and then we'll going to discuss about few more points on this logical operators. Okay, so let us just take some of the examples. So you can start with the bool, there is no issue. So bool f equal to, suppose if I write 4 greater than 5 and logical or 6 less than 7. Okay, one, then another one. Okay, now suppose 4 equal to 5 and logical and then suppose 6 less than 5. Okay, so we'll see. Third one, so let us take all the examples. 4 not equal to 5 and logical AND operator is 6 greater than 5. Okay, okay, let us just add another one. Bool f4 equal to, now suppose 4 is greater than 5 and logical OR operator 5 equal to 5. Okay, so now let us print them one by one. So let us print all of them together. One printf statement will be sufficient. So we have a 4 outcome. Okay, so let us just understand their working process. Then definitely we'll match our evaluation as per the understanding with the compiler output. So this is the process normally we follow. Okay, this is the process we normally follow to work with them so that we can understand their working process. Fine. So let us take the first one. Okay, so we have taken now two conditions. Here you can see two conditions. This is the first condition and this is the second condition. Okay, as I mentioned during the discussion, we normally write the condition with relational operators. Okay, so in a normal program we are not written the condition in this way. We normally put this condition in the if statement. It can be either true or it can be false. Now if we just for the time being just consider that any particular expression, okay, that written with the relational operator will be evaluated first and then it will consider the logical operator. We will discuss precedence later. Okay, fine. So here if I just consider this part will be evaluated first. So 4 greater than 5 is true or false. 4 greater than 5 is false. So it will give me the outcome 0. And remember it is logical OR. In logical OR what we have mentioned returns true if any one condition is true. It needs any one out of these two. So we have now two conditions. This is the first condition, is already false. So now let's look at the second condition. 6 less than 7, is it true or false? It is true. So in C programming, true means 1. So the outcome of F1 will also be 1. Right? Fine. So now let us see the next one. 4 equal to 5, it is already false. So false, and careful before you evaluate the other side of the condition of logical AND need both. Relation true if both condition, check it here, relation true if both condition is true. Okay, here it is also written both condition is true. So here you can see the first condition is already false, so we can directly write the outcome of this expression as false. No need to evaluate the second part of the operator, right? Now third one, so 4 not equal to 5 is true or false? It is true, so let's write 1. And 6 greater than 5, is it true or false? It is also true. So now both of them true, so outcome will also be true, right? And now final one, 4 greater than 5 is true or false? False. Okay, now let's check the second part. 5 equal to 5, yes, is it true? Yes, it is true. So any one outcome will be true. Okay, so now let us check with the compiler. Okay, now see the outcome. It is fine, totally fine. Whatever we have evaluated, you can see out first one is true, so we get true. Second one is false, so we get false. Third one is true, so we get true, and fourth one is true, we also get true. Okay, so before just you can easily remember if you just remember one table. So let's assume that P is one condition, right? Q is another condition, okay? And we want to find P and Q, and we want to find P or Q, okay? So truth table kind of stuffs. Okay, so what will be the outcome? So if we start with 0 0, one outcome, 1 0, another outcome, 0 1, another outcome, and last outcome is 1 1. Just note down this table, you can easily recall. So consider this P and Q are what? The condition. Which condition I am talking about? I am talking about this particular condition. Okay. So now here you can see if both the condition outcome, if both the condition is evaluated to false, then AND operation is all and OR operation both will be false. Okay. But if P is true, the first condition evaluates to true, but the second condition is evaluates to false. In such case, logical AND operation will be false, but logical OR operation will be true. Third one, first condition evaluates to false, but second condition evaluates to true. In this case also, OR evaluates to true, but the AND will be evaluates to false. Both the condition evaluates to true, then and then only the AND will evaluates to true, and definitely OR will also be true. So very easily you can remember most an important part here. See, once the first operand, okay, once the first operand of logical AND operator is false, the outcome is also false. No need to wait for the second operand. You can take this example here. 4 equal to 5 is outcome of this expression is already false, so you can see the final outcome is also false. No need to check 6 less than 5. See, even I did not also check. So remember, logical AND operator will consider the second condition if and only if the outcome of the first condition is true. Okay, so take a snapshot, note down this. I am moving to the another example. I did not discuss anything with the logical NOT. Okay, so let us move to the logical NOT. Okay, so now we already have the expressions, right? How they're evaluated. Now let me just use logical NOT in front of them and put everything under the parenthesis. Now you just remember what outcome we have received without logical NOT, so that you can see how logical NOT can alone change the overall outcome. So it is used to invert the overall outcome. Okay, so if you remember previously we have evaluated that this particular expression will be written here also true. This one is also, this one is false, this one is true, this one is true. Now what we have written, we have put logical NOT in front of them. Okay, so let's back to the theory. What is the purpose of logical NOT? You can see here that I have written inverse the logical value of a condition, true become false and false become true, right? So it will now become false, it will now become true, it will also become false, it will also become false. So now this one will be our final output. So let's check with the compiler. Now see the output. First one is false, right? So we get it the false. Second one is true, we get it true. Third one and fourth one both are false, we also get false. Okay, so whenever you apply a logical not operator, it simply reverts the final decision. Simple. Okay, so I hope now you understand, right? Very simple topic, not complicated much. Okay, now another point I need to discuss, shortcut behavior. Short circuit behavior. Okay, short circuit behavior. So now let us focus here, relate to the logical operator. As I just mentioned, logical AND operator, for the logical AND operator, if first condition is false, then second condition is not evaluated. That means compiler not even considered for evaluating the second condition. Okay, so it will save the time. Simple. So that's why it is called short circuit behavior. On the other side, logical OR, if the first condition is true, then no need to evaluate the second condition. Okay, no need to evaluate the second condition. Fine. So let us take an example to make you understand this. You'll get this code in the description of the video, so that you can also practice. Okay, so now let me just use some variable to make you understand. The left hand side not true, right hand side will not evaluated. Okay, so I'm taking now a equal to 10, and here again I'm going with the bool just for a simple explanation, right? So I'm written 4 less than 5, and logical and I have written suppose a plus plus. Okay, so let us just put this one printf here. And see. Okay, another example, let us just write another example. So let me just consider it as f1 again, f2. Now purposefully I am going to make the left hand side or the first condition of the logical AND will be false. So I am writing now 3 equal to 5, and I am using logical AND, and I am writing pre-increment operator. Okay, and let me just print this. Now I'm going to print both. So backslash n, first of all I'm going to print the f, right, and second I'm also going to print a, because a is going to update here as well. Okay, similarly here also, first one is f1, the final value. Okay, so there will be f2, this one will be the f2, and we also need to check the value of a, because it is part of the expression. Okay, and let us just try with another combination, f3. Now I'm going to use logical OR operator. 5 not equal to 3, and I'm using logical OR operator. Now I'm using a minus minus, and now let us just print it and check further. So now f3 and f3, again last one. Okay, now it is f4. Suppose now I'm going to write equal to, so it will be false, it will come on this side, and I'm using now pre, and now it will be our f4. Okay, so remember what we have discussed, right? Now let us see. So what we have mentioned that in the short circuit behavior, this is logical AND, right? It is false. So compiler will not consider the second operand or second condition. Okay, fine. Logical OR, it is false. It will be going to evaluate. Will evaluate. Okay. Uh, True, logical OR will not considered. Fine. And true, logical AND will evaluate. Okay. So let's follow this criteria here. Again, relational part will be evaluated first and followed by the logical part. Do not confused. 4 less than 5 is true or false? True. So 1. It is logical AND operator, right? So logical AND operator, this side is true. So it will also evaluate the second part. So let us now evaluate. So what we have? We have a plus plus. So it is post increment. In post increment, first assign the value. So what is the value? A value is 10. So I hope you remember during the bool data type, we mentioned that all positive and negative values are treated as true and only 0 will be considered as false. So here 10 is positive value, okay, so it will be considered as true. So now true and true, check the table that I have drawn few minutes back. True and true, outcome will be true. Okay, so now we get the F1 as true. And what about A? We have done the increment for A. Irrespective of pre or post, A will going to update by 1. So A will become 11. Okay, let's move to the next part. For F2, we have written 3 equal to 5. So 3 equal to 5 is true or false? It is false. That is 0, right? And okay, some mistake in the code. Yes, now it is correct. And it is logical AND operator and my first operand is already false. So logical AND operator, first operand is already false, so it will not evaluate the second operand. So that means there is no change in the values of A because this particular part will not considered by the compiler. So the F2 outcome will be 0 and A remain unchanged. A already 11 here, so A will also going to print 11 here as well. Okay, we'll see, don't worry. So now let's come to the logical OR part. 5 not equal to 3, true or false? True, so it is already 1. So now look at here, logical OR operator. First part is already true, the second part will not evaluate. Okay, so that means A minus minus will not going to be evaluated by the compiler. Okay, it will simply give the final decision. So final decision will be true because the first operand is already true. Okay, first operand is already true. So what it will print? It will print true here, and for the A there is no change. We have the value as 11 as well. Okay, last one here, 5 equal to 3, it is false. Okay, so for the logical OR operator it is false, so it will evaluate the second part. So it is moving on the second part. So now here it is pre-decrement minus minus A. So what is the value of A? A is 11, so first it will decrement to 10. So 10 is what kind of value? Positive value. So what it means? It is true. So outcome of this expression is true. So final outcome of the expression will also be true because it is logical OR operator. Any one condition true, outcome is also true. So F1, F4 will be true. It will print true. And what about the A? Because A already decremented by 1, so it will also going to print 10 here. Okay, so now let's evaluate the code and see our theory and outcome is same or different. Okay, now look at the output and check here. First one we get F1 as 1, so here you can see F1 as 1, yes, correct, and A as 11, yes, here you can see A as 11, we got it correctly. Second, F2 as false, so F2 as false and A as 11, so you can see A as 11. Third one, F3 as true. So F3 as true. A still remain unchanged. A is 11. So you can see A is 11. No issue. And last one, F4 as true. Yes, it is true. And A is 10. A is also 10. Okay. So our theory and the implementation of the code in the compiler are same. So it means what? It means their behavior, means order of execution is defined. That's why we can predict the answer. It is not like our pre or post increment decrement, that when if an expression contains multiple times pre and post on the same variable, we cannot predict. Only this two operator has behavior undefined, means order of execution, but this order of execution is defined. So whatever we predict, we get the same answer. I hope you understand this. Okay, so now let's combine all the operators together. So only last topic remains, that is precedence of the logical operator as compared to the other, along with the associativity. So I hope you remember I mentioned that unary operators are always higher in precedence. So we have a unary unary logical not. Okay, so logical not you can see on the top of the table. You can consider all these unary operator at the same precedence as of now. Okay, because they're going to execute individually, they are not going to impact the complete expression, only individual part. So you can mark them same precedence, or you can follow this particular order, will get the same result. There is no issue. Logical not top of the table, and like other unary operators, logical not is also follow right to left operator associativity. And the logical two operator that are requires two operand, so their nature is binary. So binary, always the associativity is left to right. But in the table you can see, after the relational operator, logical operator falls in the precedence. So out of these two logical operator, logical and is the higher in precedence as compared to the logical or, means logical and will be evaluated first. Okay. Let me just check how much time we have done. 27 sufficient. I think it is sufficient. Normally we are not mixing them. If whenever we mix them in an expression, our condition become little bit complex, and it reduce the readability of the code. So even though we mix them, we do the proper parenthesization, right? So that any other person who did not write the code can easily understand the overall outcome of the expression. Okay, do the parenthesization whenever you are mixing logical and logical or operator, so that you can predict the behavior of the compiler. Okay, I hope you like this content. Okay, please do share this video with your friends, and do not forget to like and subscribe our channel. Thank you very much. Have a nice day ahead.